Hello guys, welcome to my channel. So till now we have covered as 15 days SQL series completed. Okay. For some additional content, I'll cover as day 16. So till day 15, I covered as all the basic stuff like SQL beginner stuff. Everything, every concept is covered in 15 days SQL series. If anything missing in the concept, please ping in the comment. I will cover the content for that one. Okay. So for day 16 to day 20, I'll cover as like advanced SQL. So in day 16, we mainly focus as common table expressions and recursive queries. So in day 16, mainly this CTEs part, like common table expressions and recursive queries. So mainly CTEs help simplify the complex queries and allow us to perform recursive operations such as retrieving hierarchical or tree structure data like organizational chart. So main thing in this video we had to cover as three parts. So one is the introduction to CTEs, that is common table expressions. And second thing, use of CTEs to simplify complex queries. Third one, recursive CTEs for hierarchical or tree structures. So for the first part, introduction to CTEs. So for the introduction to CTE, first of all, a CTE is a temporary result set. So common table expressions is a temporary result set that defined within the execution scope of a single select, insert, update, or delete statement. The execution of single select or insert, update, or delete statement. So it can make queries easier to read and maintain by breaking them into a simpler parts. Okay. So let's look into the syntax of CTE. So we'll write as with class. So with CTE name and optional column list as and write the SQL query. And once we done with this the CTE part, okay, after then that CTE name is there. So whatever the CTE name, that will follow up the query to use the CTE. So select star from CTE name. So this is the just syntax of CTE. Okay. For simplifying complex queries with CTEs. So for this, we have take one scenario. So let's say we have a sales table and we want to calculate the total sales per employee. We have the sales table and we want to calculate the total sales per employee, then filter only employees with sales above 5,000. Okay. So for this, I have considered as this sales table. So in this sales table, I have considered as sales ID, employee ID, sales amount, and sale date. Okay, sale ID will create as unique, that is identity. It will create as the serial number. Okay, automatically generate the ID, and we have to insert the values for sales. So sale ID, employee ID, sale amount, and sale date. So sale ID, it will identity, it will auto generate, and employee ID, this one, sale amount, and sale date. So we have to insert the values. After then, our task is mainly to retrieve the employees data with total sales above 5,000. Okay, so here we have the sales called as, so for example, sale ID. So sale ID 1, 2, 3, 4, 5, right? That is employee ID, retry the employees with the total sales above 5,000. So for example, here 7,000, okay, like this. If you consider as sale ID 1, this is 5,500. For sale ID 2, 11,500, like this. So above sales, retry the employees with total sales above 5,000. By using CTE, we had to do this one. So by using CTE, first we had to get the total sales. Okay, each and every employee wise, ID wise. First, I will write as select from. So from part is sales. Okay. Now I will write as select part. So select part, I want employee ID, comma. We want total sales. So that is sum of sale amount as total sales. Okay. So up to this one, fine. Employee ID, sum of sales. So when you write with sum of sales, we want total sales for each employee ID wise. That is group by. So group by employee ID. So we will get the each employee ID, the total sales. So employee ID 1, 5,500, 2, 11,500, 3, 1,500. Now what we can do, filter. So total sales above 5,000. So filter. First this one will save as with CTE name. So with CTE called as, so for example, employee sales as this complete thing I will put as in the CTE. Okay. Now we'll write the filter condition. Select part, select from is employee sales. Okay. Now we'll write the filter condition. So what is the filter condition? Total sales. So this total sales greater than 5,000. Now select part. So select part, what we had to require, employee ID and total sales. Okay. Done. So let's execute this one. Syntax error. Greater than. What is the error? Where condition. Sorry, missed that. Where total sales greater than 5,000. Okay. Now we get the above 5,000. So 5,000 employee ID 1, 5,500, 2, 11,500. Okay. With simple query, we'll get the retry the employees with total sales above 5,000. Okay. Next, we'll look into third part, recursive CTEs for hierarchical data. So in this part of recursive CTE, a recursive CTE is a CTE that references itself within its definition. So making it ideal for traversing hierarchical or tree like structures, such as organizational charts, bill of materials, or family trees. So in this, we have to create with some example. So the example is we'll consider as so example we have to consider like employees table. So in employees table, we have to create employee ID, employee name, manager ID. So for this inserting data called as so employees, employee ID, employee name, manager ID. Then our task is here use a recursive CTE to display the hierarchy starting from Alice. So first let's look into this hierarchy. So Alice is the CEO, the first record. Bob, Bob and Charlie report to Alice. So these two records, Bob and Charlie report to Alice. Right? David and Eva report to Bob. Frank report to Charlie. Right? So now we had our requirement is use recursive CTE to display the hierarchy starting from Alice. Okay. So first what we can do is our top level employee Alice. Okay. So first anchor member, like anchor member, select the top level employee Alice. So first we will display the manager level. Okay. So let's write this one. Select from, so table name called as the employees. Okay. So now here select part I will write as so EMP ID, EMP name, EMP name, manager ID. Okay. So and we want level. So here I will take as 1 as the level, just for the for assumption of 1 as level. Okay. Now up to this one fine. If I execute this one, so invalid column name employee ID, EMP ID, EMP underscore ID. Okay. So if I execute, I will get that this way. So if you look into this table, employee ID, employee name, manager ID, and level. So level called as by default, I will create as the 1. Now we had to filter it now. So how I can filter it? Where manager ID is null. Okay. So why I have considered as null called as first record as the null. So CEO. So if I execute this part, I'll get the first record as null. Okay. So this entire thing will save as in CTE with employee hierarchy as up to this one. Okay. Now we'll write as the other part. So other part called as select from employees. Again, I will write the employees only. Okay. Now here we'll write the select part. So this select part is for example, employees E, I will consider employee ID, same thing I will copy. Okay. So let's consider as E dot EMP ID and E dot EMP name, E dot manager ID, and here we'll consider as this one like so for time being we'll write as 1 as level. Okay. And we had to join this one. So employees E join to which one? So above this employee hierarchy. So join to employee hierarchy. So this employee hierarchy will call as EH on condition. On condition is manager ID here. So manage like employee table manager ID equal to hierarchy table employee ID. On E dot manager ID equal to EH dot employee ID. Okay. So here we have alias name called as so this EH. So let's write this one level as so eh dot level plus 1. Okay, and remove other things. Eh dot level plus 1. So plus 1 called as, after then each and every level will addition to 1. Okay, done. So up to this part, this is fine. Okay, so we'll get the 2 Bob Charlie 1 like this. Now what we can do, final select we had to write. So the final select is so select from. So from what we had to write, employee hierarchy. This entire CTE we have stored. Okay, and here we'll write as employee ID, employee name, manager ID, employee ID, employee name, manager ID, comma level. Okay, so this entire thing will order by level. Okay, now let's execute this entire thing. 2 rows affected, invalid object name, employee hierarchy. Okay, so something we had to close here. This one. After then, okay. So let's do one thing. So here we have executed this query. So this we are getting, sorry, this we are getting first level, level 1. Okay, and this one we are getting this entire thing. We are getting the this second part. So, but this one is missing here at the time. So let's do union all. Union all. Okay, and we had to close this query. This CTE will close as at the end. This one after join condition. Okay, now we'll execute with this entire thing. Now we are getting with union all called as a first null condition, that is CEO alias, and after then the second part is we are getting. Okay, so if you look at the condition here, I will write the comment lines. So this is the final select part. Okay, final select part. After then, after union all. So after union all, this is the recursive member. This is recursive member. So in this recursive member, select employees who report to the previous level. Like here, I will write select employees who report to the previous level. Okay, and the first thing. So first part called as the anchor member. Anchor member means that is the first top level. Select the top level. So top level called as Alice. Okay, so this entire thing will get what happened. Okay, comments. So this entire thing will get the result of the hierarchy. So recursive CTE to display the hierarchy starting from Alice. Okay, level as 1, 2, and 3. Okay, right. Next one. So fourth one called as additional recursive query example, family tree. So in this, let's say family tree called as, so let's say we want to model a simple family tree where each person has a parent we can use recursive CTEs to find all descendants of specific ancestor. So specific ancestor called as, for example, if we consider as family table, here in this family table, person ID, person name, parent ID, and insert some records. Okay, so the inserting records are inserting here. First, the family structure looks like first grandparent, parent one, child one, child two. Next, grandparent, parent two, child three. Okay, so this is the actual the family structure. So our task is here mainly use a recursive CTE to find all descendants of grandparent. Okay, so first what we can do, start with the grandparent. So top level ancestor. So top level ancestor is mainly first select from family table. Select part is we'll get the person ID, comma, person name, comma, parent ID. Okay, so this is the we'll get the three columns. So in this part, first top level grandparent null. So where parent ID is null. So we'll get the first part null. So this same thing we have to store as in with. So the CTE name called as family tree as open braces. Okay, close it here. After CTE part is over. Now we'll get the recursive part. So in recursive part, above same thing only. So above we'll write the recursive part, right? That is same thing. So here I will write as select from family F, join. So which one we had to join? Family tree. So family tree called as the FT on F dot parent ID equal to FT dot person ID. Okay, so this is the join condition. Now same thing we'll write as select part. So here I will write as F dot person ID and F dot person name, parent ID called as F dot parent ID. Okay, so if I execute this complete thing, okay, parent one, parent two. So like we can write as union all. So remove the braces with CTE and write as union all and close the braces here. So this is complete CTE part up to this one. Now we'll write as select, final select statement. So final select from family tree. Select part is person ID, person name, and parent ID. Okay. Now we are getting the person ID 1, grandparent null, parent ID. Now second part, parent 1, parent 2 is first generation. Child. So this is second generation and third generation. So if we want order by, then we'll write as order by parent ID. Okay. Now order by parent ID, we will get the order wise. Okay, 1, 2, 3. Okay. First generation, second generation, and third generation hierarchy. So in this part, we'll write the comment here. So this is the final select. This is final select. So first part is the this one. after CTE, we'll get the start with grandparent. Start with grandparent, that is top level. After union all, this one has the recursive part. So recursively get all children of the previous level. Okay. So this one. So this one finally will get the output. Right. So next part is the practical example organizational structure with departments. So in this one, if we consider as in the real world applications, the recursive CTEs can be used to model the organizations with departments and sub-departments. So let's say, for example, here, head office, that is the top level department, and sub-departments, sales, marketing, North America sales, Europe sales, etc. So for this, we require the departments table and insert the records, this one. So for this, inserting records are mainly top level is head office. Okay, let's consider the task. So our task is mainly use recursive CTE to find all subdepartments of head office. So first we'll get the top level. So for top level is select from table name departments. We'll write the select part DEPT ID, comma department name, comma parent department ID, where parent department ID is null. Okay. So if I execute this part, I'll get the first top level. This one will store it in the CTE, that is department hierarchy as this one. So up to this one, first top level is completed. Next we will write the recursive part. So recursive part is from departments D join to CTE. So this CTE called as DH on D dot parent department ID equal to DH dot department ID. Okay. So let's remove this one and write the union all and close this one and write the final select. Final select is select from department hierarchy, and select part is the 3 columns. So department ID, department name, and parent department ID. Okay. Now let's execute this part. Incorrect syntax from select from something is incorrect syntax near the keyword from, where it is FROM from select here. Here select part is missing. So here we'll write the select part D dot department ID, D dot department name, and D dot parent department ID. Okay. Now let's execute. Okay. So I will get the first to head office, next to sales marketing, next to North America sales and Europe sales. So first, what is this one? Start with the top level department. Okay. After then union all. So in this union all, this is the recursive part. Recursively get all sub departments. Okay. So this way we'll get the complete this one. Okay. So this is the final part. So for the conclusion is mainly in this video we have covered as mainly we learned about CTEs, including recursive CTEs and how they help simplify complex queries and retrieve hierarchical data like employee hierarchies, family trees, and department structures by breaking down the queries into manageable parts. CTEs improve the readability and maintainability of this code. Okay. So this is the complete day 16. Thank you. Thank you for watching. We'll meet day 17, some additional advanced concept. Okay. Please like and subscribe if you like the content. Thank you for watching.